Our next topic of discussion is the average value of a function. So this is the expression that we're going to use to determine what is called average value. And the meaning of this is really the height of a rectangle we could use to determine the area under our curve bounded by our closed interval a to b and above the x-axis. This is an illustration of the average value of a function. So let me explain. If we were asked to come up with a definite integral over this closed interval from a to b on the graph of this function f, then that value would be equal to everything shaded here in green and yellow. All right, that'd be the actual result of our definite integral of this function over the interval from a to b. Now, what the average value is going to do for us is just give us this height from here to here. All right, that's what the average value is going to do. And so you can see that the height of this rectangle, all right, times the width, which would be whatever the difference is from a to b, would be easily determined. It's just the area of the rectangle. And so what we're doing is we're going to actually look at the area of this rectangle and compare it to the area underneath this curve, which would be everything in green and in yellow. And you'll see that in the next example. All right, let's finish the notes for section 11.5. So let's go ahead and determine the average value of this function over this closed interval, -2 to 3. So what we're going to do is we're going to follow the formula, which would tell us to do what? It would tell us to do 1 over b, which is 3, minus a, which is -2. That's the only difference here when determining the average value of the function. Everything else is going to be handled exactly the same way. So because we're looking at this interval from a to b, your a value would go down here. It's your lower limit of integration. Your 3 is going to be your upper limit of integration. What are we integrating? We're integrating this function f with respect to x. So what does this give us? Here is what it gives us. First, we now have this constant preceding our integral. So 1 over a negative times a negative is a positive. That's 1/5. And let's go ahead and integrate this. Notice no substitution required here. That's nice. So we end up with what? 4x, that's the integral of 4x. And the integral of x squared is x cubed over 3. And we're going to run this based upon these limits of integration. Okay? All right. So let's come down here, bring down the 1/5, and let's rock and roll. So this is going to be a little lengthy. Let's see what we have here. So the first part would be every x becomes a 3. That's our upper limit of integration. So that would look like this. And we're going to subtract what? Whatever we get for our lower limit of integration. Okay? And that would look like this. So go ahead and get your calculators out if they're not out already, and let's go ahead and compute this. So we get 1/5 times what? That's going to give us a 3 minus, I'm computing, that's going to give us a -16 over 3. And so what is this equal to? Well, 1/5 times whatever we get in the brackets, which I believe is what? 3 plus 16/3 is 25/3. So the result here, the average value of our function f over this closed interval from -2 to 3 would be what? 5/3. Now, just to show you briefly, again, the meaning of this, if we were to just look at the average value of this function over this interval, you would get this for your average value, same as the height. Notice if you take the height, 5/3, what we just came up with, and multiply it by, well, the distance from -2 to 3, which is 5. That's your width. Notice the product of these two values is equal to what? It's equal to the actual value of your definite integral of 4 minus x squared based upon these limits of integration. All right? You just need to know how to determine the average value and write down the answer. Okay? You're not going to have to show this. I'm just trying to convey to you the meaning of average value. Have a wonderful day.